Today we're going to look at this series of questions. How many molecules of cyclohexane are in the container? The density of cyclohexane is 0.78 grams per milliliter. Okay, looking at question number 1, we're at 250 milliliters. We're going to use the density here to go from milliliters to grams. So for every 1 milliliter, we get 0.78 grams of cyclohexane. Now that we have grams, we can move from grams to moles. So cyclohexane is 84 grams per 1 mole. Now that we're in moles, we can move to molecules. And so for every 1 mole, you get 6.022 times 10 to the 23 molecules. Okay, now we're in the unit that the question asks. Now we go through and we cancel units until we get to the unit that we want to be. So we can cancel milliliters because you have milliliters in the numerator and milliliters in the denominator. We can cancel grams, we can cancel moles, and we're left in molecules. So now we want to multiply across the numerator and across the denominator and then divide. And that gives us 1.40 times 10 to the 24th molecules. And that's it for that one. Let's look at the next one. All right, the next one is, how many atoms of hydrogen are in the container? So we're going to start off with 250 milliliters. We're going to convert milliliters to grams again. So for every 1 milliliter, we're going to have 0.78 grams. We're using the density. And now that we're in grams, we can go to moles. So for every 84 grams, we get 1 mole of cyclohexane. And little side note, the way I got 84 grams, that's the molar mass of cyclohexane. That can be calculated. If you look at the formula for cyclohexane, so you have the AMU for carbon, 12, so 12, and then the AMU for hydrogen is 1. And what I did is I took 6 times 12 plus 12 times 1, and that equals 84 grams per mole. So that's how I got that, if you're wondering. And then, now that we're in moles, we could go 1 mole of cyclohexane, so carbon 6, hydrogen 12, and then for every 1 mole of cyclohexane, you get 12 moles of hydrogen. Okay. Now that we are in moles of hydrogen, we can go into molecules of hydrogen by using Avogadro's number. 6.022 times 10 to the 23rd molecules. Why can't I write molecules today? Molecules. Okay. Now we can go through and we can cancel units. Milliliters cancel out, grams cancel out, moles cancel out, moles again cancel out. We're left in molecules. Now after that, you multiply across the numerator and the denominator and then divide. And so I made a slight mistake. Molecules here is the same calculation to get atoms. And so what we end up with in our final answer is 1.6 8 times 10 to the 25 atoms of hydrogen. And that's it for that one. Okay, now for the next one. How many molecules of cyclohexane would there be in a 1 gallon bottle? So we start off with 1 gallon. Now we need to go from 1 gallon to liters. So if we look down here on our conversion table, 1 gallon is 3.785 liters. So every 1 gallon, we have 3.785 liters. Now we can go from liters to milliliters. So for every 1 milliliter, we have 10 to the negative 3 liters. Now that we're in milliliters, we could go to grams. So for every 1 milliliter, we have 0.78 grams. And now we have grams, we can go into moles. For every 84 grams, we have 1 mole. Now we can go from moles to molecules. For every 1 mole of cyclohexane, you have Avogadro's number. And I'm not going to write it for the sake of space. So this is molecules. Okay, now our units can cancel. We can cancel gallons, we can cancel liters, we can cancel milliliters, we can cancel grams, and we can cancel moles. Now we're left in molecules. Now we have to multiply across the numerator and across the denominator and then divide. And that gives you 2.11, actually that gives you 2.12 times 10 to the 25 molecules of cyclohexane. And that's it for that one. Okay, now for the last question. If 500 milliliters of cyclohexane evaporates from an open beaker in 18 hours, how many molecules on average leave the beaker each second? So this one we're going to start off with 500 milliliters. And we need to convert milliliters per hour to molecules per second. So we need to convert this from milliliters per hour to molecules per second. So we have 500 milliliters per 18 hours. So let's convert hours to second first. It's the easiest one. So for every 1 hour, and the reason why we're writing that on the top because we need to cancel these units. So for every 1 hour you get 3,600 seconds. And we can find that on our chart down here, right here. So now we're in seconds. Now we need to go from milliliters to molecules. So now we need to go from milliliters to molecules. So for every 1 milliliter, we are using the density again. We get 0.78 grams of cyclohexane. And now we're going to go from grams to moles. We have 84 grams of cyclohexane per 1 mole. And then we're going to go from moles to molecules. So 6.022 times 10 to the 23. Oops. Times 10 to the 23. And these are molecules running out of space. Okay, now we can go through and cancel units. We can cancel milliliters. We can cancel grams. We can cancel moles. We can cancel hours. And now we have seconds per molecules. Now, same thing, multiply across the numerator, multiply across the denominator, and then divide. And that comes to 4.31 times 10 to the 19 molecules per second that evaporates. And that's it for these series of questions. If you have any other questions, email them to me. If you have any questions about how I did these problems, email them to me. If you find any mistakes that I have made in any of my videos, email me. And that's it. So thank you for watching, and I will see you all in the next video.